The James Webb Space Telescope has finally seen what's inside a black hole, marking a major breakthrough in our understanding of this mysterious cosmic phenomena. Black holes and the strange laws of physics that govern them have captivated astronomers for a number of years. However, until this point, our understanding of what goes on inside of these dark entities has been constrained to the realm of theoretical models and indirect observations. All of that is about to change, thanks to the James Webb Space Telescope and the sophisticated infrared imaging capabilities it possesses. The telescope's unique ability to gaze deep into the heart of distant galaxies is providing astronomers with a plethora of new data about the behavior of black holes and the things that surround them. This information is helping scientists better understand how galaxies form. However, what specific information have we gained about the contents of a black hole as a result of observations made by the James Webb Space Telescope? And what does this new information mean for our overall understanding of the cosmos and everything in it? In this video, we will discuss this and many other questions. First and foremost, it is essential to have an understanding that black holes are among the most extreme objects that can be found in the universe. They are produced when enormous stars, in the process of collapsing in on themselves, do so in such a way that they create a region of space in which the gravitational pull is so powerful that nothing, not even light, can escape. This indicates that black holes are, for all intents and purposes, invisible, save for the effects that they have on the matter and energy in their surroundings. For many years, researchers have relied on indirect ways to investigate black holes. One example of this is the observation of the radiation emitted by the extremely hot gas and dust that surrounds black holes. However, these discoveries have only given us a rudimentary comprehension of the processes that are taking place inside of a black hole. The James Webb Space Telescope was designed specifically with this purpose in mind. This is made possible by the telescope's sophisticated infrared imaging capabilities, which enable it to see directly through the dense clouds of gas and dust surrounding black holes, and provide us with a clear view of the objects themselves. The presence of a supermassive black hole in the center of a faraway galaxy, known as NGC 3256, was one of the most significant findings made possible by the James Webb Telescope. This particular black hole has a mass that is approximately 100 million times that of our Sun, and it is encircled by a whirling disk of hot gas and dust that is being dragged in the direction of the event horizon. Astronomers have been able to discover that the black hole is spinning at a pace that is approximately 84% of the speed of light. The spin of a black hole may now be directly measured for the very first time, thanks to this astounding discovery, which breaks new ground in scientific achievement. But the James Webb Telescope has done more for us than simply improve our understanding of black holes in and of themselves. In addition, it has allowed us to gain new understanding of the things that surround them. For instance, the telescope has shown that there are enormous clouds of gas and dust being expelled from the neighborhood of black holes at extremely high speeds. These outflows, which are believed to be created by the tremendous gravitational forces that are located around the event horizon, are believed to play a pivotal role in the process of how galaxies evolve through time. Astronomers are hoping to gain a better understanding of how black holes contribute to the expansion and development of the universe as a whole by paying closer attention to the details of these outflows during their research. However, the detection of gravitational waves that were produced as a result of the collision of two black holes by the James Webb Space Telescope is possibly the most fascinating finding that the telescope has made thus far. When two large objects collide and combine, they create ripples in space-time, which Einstein's theory of general relativity predicted would occur. These ripples in space-time were initially predicted by Einstein's theory. Because it enables us to investigate the cosmos in a manner that was not possible before, the discovery that gravitational waves were produced by the merger of two black holes is an important step forward in the discipline of astronomy. Astronomers are now able to gain insight about the characteristics of the objects that generated these waves, such as their mass, spin, and location, through the practice of studying these waves. In general, the James Webb Space Telescope has been very helpful in supplying us with a lot of new information regarding black holes and the things that surround them. This data is helping to shed light on some of the most fundamental topics in the field of astrophysics, such as how black holes arise, how they evolve, and how they interact with the galaxies surrounding them. However, perhaps of much greater significance is the fact that the James Webb Telescope is motivating a new generation of scientists and researchers to keep delving deeper into the mysteries of the cosmos. Because of its unparalleled capabilities, the telescope is allowing us to explore previously inaccessible new research routes, which in turn assists us in the discovery of previously unknown and fascinating cosmological phenomena. As we look into the future, it is abundantly clear that the James Webb Space Telescope will play a significant part in the development of our understanding of the cosmos as a whole, as well as our location and purpose within it. The telescope, with its cutting-edge technology and sophisticated imaging capabilities, is set to produce even more groundbreaking discoveries in the years to come. In conclusion, the James Webb Space Telescope has given us a glimpse into the center of black holes, never seen before. As a result, we now have a deeper comprehension of these unexplained phenomena. The telescope has made possible a number of previously unattainable lines of inquiry, including the observation of supermassive black holes and the detection of gravitational waves. As we continue to investigate these fascinating occurrences, we can be confident that the James Webb Space Telescope will continue to play an essential part in increasing our comprehension of the cosmos and the place we occupy within it. Let us know your thoughts about what you think is inside a black hole in the comment section below, and make sure to subscribe to our channel and be the first to know when we post new content.